Have you ever wondered what an algebraic expression really is, or how it's different from an algebraic equation? Maybe you struggle to write expressions from word problems or evaluating powers. Today, we're covering everything you need to know about algebraic expressions, all in one video. Let's dive in. You might ask, what is an algebraic expression? The definition of that is, it is a mathematical phrase that contains variables, numbers, and operations, but it does not have an equal to sign. You would not see that in an expression. Some examples of algebraic expressions are 3x plus 5, where 3 and 5 are the constants, also known as the numbers, and x is the variable. Take another example, 2a squared minus 7b plus 4. I'll let you figure out which ones are the numbers and which ones are the variables. The main difference between numerical expressions are that numerical expressions contain only numbers, while algebraic expressions contain variables, like in this case. Here's a real-life example of some algebraic expressions. Take, for example, you're shopping. If an apple costs X amount of dollars, right, then 3 apples would cost 3x. Now, you may be wondering, what is the actual difference between algebraic expressions and algebraic equations? Here's a table to show you the difference. For algebraic expressions, there are no equal to signs. However, for algebraic equations, there are. Look at the word equation. Look at the equal to sign right here. This is an example of an algebraic expression. It has no equal to sign present, but this one does, and it's equal to 18. Algebraic expressions are not solvable, but they can be simplified. However, algebraic equations can be solved. In this case, we find x. Now, which one of these is an equation and which one is an expression? Comment down below your answer. Section 3, properties and rules of algebraic expressions. Here are some key algebra properties and examples to follow. Number 1, commutative property. A plus b equal to b plus a, and a times b equal to b times a. Here are some examples. Let's take, for example, 4 plus 7 is equal to 7 plus 4. And they give the same answer, 11 equal to 11. And we can do the same for these. We can also say 4 times 7 equal to 7 times 4. And they both equal to 28. Property number 2, associative property. A plus b in parentheses plus c is equal to a plus b and c in parentheses. We can take, for example, let's keep our 4 and 7 from above. 4 plus 7 parentheses plus 5 equal to 4 on its own plus 7 plus 5. Let's work on this together. 4 plus 7 equal to 11. We can still keep that in parentheses. Plus 5 is equal to 4 on its own plus 7 plus 5. You got that right. 12. Your answer, 16 equal to 16. Let me know if you worked that out yourself and if you got the right answer. Number 3 is distributive property. A multiplied by, which parentheses right here is representing a multiplication operation. A multiplied by b plus c, parentheses closed, is equal to, you can distribute a multiplied by b and a multiplied by c, as you have here. A, b, which are multiplied together, plus a, c. Do you see how that works? Let's see the next property. This is an interesting one, identity properties. You have a plus 0 and a times 1. They both give you the same answer. So what we're looking at is a plus 0 and also a times 1. These are the identity properties as related to algebraic expressions. Under identity properties, we have inverse properties. This is where the positive of a number plus the negative of that same number would give you 0. It makes sense. In this case, 4, positive 4 plus minus 4, it would certainly give you 0 because 4 plus times minus equal to minus, 4 equal to 0. Okay? Now this other inverse property where you have a multiply by 1 over a, this whole term right here is called the reciprocal. The reciprocal value of a is equal to 1 when a is not equal to 0, because 1 minus 0, we can't determine that. It's literally 0. Any number divided by 0 is 0. In calculus, it is called DNE. And here you have it, guys. Section 3, properties of algebraic expressions. These rules make algebra so much easier. Section 4, writing algebraic expressions and verbal expressions. I will be sharing some common word phrases and how to translate them. In this very first one, we have 5 more than x, and that is written as x plus 5. Twice a number, 2 times x, or simply 2x. 3 less than a number, you put the number, which we would say is x, minus 3. There you have it. I will be sharing a word problem example and see what you guys think the answer is. Here's a word problem. Imagine a train is moving at 10 miles per hour, faster than a car moving at x mile per hour. What expression would you write? I'll give you a minute. You can pause the video if you want to take a moment to do it, or we can go right into it. The expression would be x plus 10. This is our answer because it tells us, the question tells us that a train moves 10 miles per hour faster. Faster tells you more. More equal to addition. Faster than a car, so we're relating it to a car. This is a relation question, by the way. Now, drop a real life world problem in the comments and I'll solve it in the next video. If you stuck up until this point of the video, you are a real one. Section 5, evaluating powers in algebraic expressions. We have a question. What is an exponent, or what are exponents? Let's take, for example, 3 raised to the power of 2. 2 right there is the exponent. It's also known as a power. Powers or exponent, right? This can be written out as 3 times 3 because you're multiplying the base 3 by itself twice. And that's indicative of this power or exponent 2. Now, we already talked about base and exponent, but let me give it in the form of letters. We have the letters B, N. In this case, what would we say? B multiplied N number of times. Again, remember this is also known as exponent or power. And B, as the letter goes, this is the base. Do not forget this. There are other exponent rules that we'll be covering, and we can also have some examples to follow. All right, here are some exponent rules that we'll be discussing. Number 1 is the product rule. This rule right here is where you have a raised to the power of m. That's what this arrow looking thing looks like. That doesn't have the tail going down. But yes, it's pretty much a raised to the power of m multiplied by a raised to the power of n. And because they share the same base, we could simply write it as a raised to the power m plus n. Remember, this is in superscript format. It's up, okay? Now, on to the next one, quotient rule. Quotient rule here, you have a raised to the power m divided by a raised to the power n. This, in other words, can be written as a raised to the power m minus n. Okay? Again, remember, this is in superscript. It is raised to the power of m minus n. It's not on the same level as this. I want you to keep that in mind. And then you have the power rule. Finally, we have a raised to the power of m, parentheses, remember, you group the expressions this way, raised to the power of n. All of this raised to the power of n can also be written as a raised to the power of m multiplied by n. Make sure you take note of this. Pause the video if you need to. Make note of this and keep that in mind, because you're going to need to use this whenever you're evaluating powers, when it comes to algebraic expressions, and it's also useful for other topics in algebra or math in general. Quick fact. Did you know that 2 raised to the power of 10 is equal to 1024, 1024? That's why computers use binary format, powers of 2. Now, a quick recap. Here's a quick recap of what we covered. What an algebraic expression is, expression versus equation differences in algebra, cool properties that simplify algebra, and how to write algebraic expressions from words and vice versa, as well as exponent rules for faster solving. Which part helped you the most? Comment below. If you found this video helpful, hit the like, subscribe, and turn on your notifications so you never miss a math hack. Until next time.